Welcome back to Algebra I Summer Prep. We are going to continue with Lesson 3 today over functions. So let me share my screen here. So functions are going to be a huge part of this year, and before we dive into what a function is, we're going to look at some stuff that you probably did learn last year over the coordinate plane. Okay, so you guys probably looked at graphing points, graphing what we call ordered pairs, and you learned about different parts of the coordinate plane. So let's make sure we have a good foundation on this before jumping into functions. Let's zoom in here. It says, label the origin, quadrants, x-axis, and y-axis. All right, so you might be able to do this already, and if you can, go for it. Maybe pause it and see if you can get that. But let's look at it together. So let's label the origin first. This is really just knowing vocab here. I'm going to use this blue color, and I'm just going to underline origin in blue, and I'm going to put the point where the origin is in a little blue dot right here. So the origin is just where the x-axis and the y-axis meet. I guess that answers our next question of labeling the x and y-axis. And it has the coordinate 0, 0. Okay, it's kind of where it's like our reference point for all of our points. It's where we start. So let's go ahead and label our x and y-axis also. I'll pick green here. Let's just underline both of these. So this horizontal one is our x-axis always, and then the vertical one going up and down is our y-axis. All right, and then we have something called quadrants. Okay, quad means 4, right? We have 4 quadrants here that, like, where our x and our y-axis meet, it kind of divides them up into these. This is just so that we can locate our points, and I know like what quadrant you're talking about. So it starts over here when the x is positive and the y is positive. We start with labeling this one always as our quadrant 1. So, and you'll see that they're labeled using Roman numerals. So the 1 I'm going to write like this. It's like a Roman numeral 1. And then you go in like a counterclockwise direction from there always. So this is 1, then the one over here is quadrant 2. And then we come down here, this is quadrant 3. And then our last one over here, quadrant 4. Okay, perfect. So that's our basic vocab with our XY coordinate plane. Now down here, this is also something that you probably did. It says, identify the ordered pair and quadrant of each point. An ordered pair is just a fancy way of saying a point or a coordinate. So we've got A, B, C, D, E, F, all these points over here, and we're going to list out the ordered pair and then also list out what quadrant it lies in. So let's start with point A. Let's zoom in here. Okay, point A, so let's locate it first. We can see where it is over here. And then the way we figure out what that is as a coordinate, if you remember, is you start from the origin and you always count like left and right and then up and down to get to that point, which kids often kind of get this backwards because I think they mistake it with slope, which is something we will talk about. You might remember learning a little bit about slope last year. It's the rise over the run. It's the opposite whenever you're naming a coordinate. So you always go left to right first along the x-axis and then up or down to get to your point. So if I start from my origin, I would count, let's see, to get to point A, we would go left 1, 2, 3. So because we're going to the left, that's the negative direction on the x-axis. So I know my coordinate is going to start with a negative 3. Okay, left 3 is going to be negative. If we went right, it would be positive. Okay, so I go left 1, 2, 3, and then I go up 1, 2, 3, 4. And because I go up, that y coordinate is going to be a positive 4. If I had gone down, it would be negative. But I went up, so it's a positive 4. And then we always do our ordered pairs in a set of parentheses. Okay, perfect. So the quadrant that this one would lie in, well, we know this one is always our quadrant 1. This one's definitely in our quadrant 2. Quadrant 2. Okay, great. If you want to try to list these out, pause this, and then fast forward, go for it. See if you can get all of these right. But we're going to go through them here. So point B, we can see is down here. You know what? I would actually label the quadrant first. So this would obviously be in quadrant 4, right? If we start here, 1, 2, 3, 4. So I'm going to label the quadrant 4. And then let's go ahead and name this point here. So from our origin, I know from our origin, I'm going to have to go to the right 2, it looks like. Right 2, and because we're going to the right, that's the positive x direction. So I know it's going to start with a positive 2. So 1, 2, and then I go down 1, 2, 3 to get to that point. And because I go down instead of up, down means we go in the negative y direction. So negative 3. So the coordinate 2, negative 3 would be our point B. Okay, good. How about C? This one's a little weird. If I ask you what quadrant is C in, well, it's like not in a quadrant, right? You wouldn't list a quadrant for this one. You could say none, or you know what? I would say for now, C is on our y-axis, so I would just say that. It's not in a quadrant, it's on the axis itself, so let's just write y-axis. Okay, so what would be the coordinate of point C? Well, I know I start from the origin, and I know I go right and left first. However, I don't have to go right or left any to get to point C, so my x coordinate for this point is going to be 0. So I know it's going to start with 0, because I don't go right and left any, and then I go up 2. So it'd be in the positive y direction, so it'd be the coordinate 0, 2. All right, point D. That one is obviously up here in quadrant 1. Let's label that. And that would be the coordinate starting from the origin. We go in the positive x direction. So 1, 2, 3, 4, 5, 6, 7. So positive 7, and then up 1. So we are the coordinate 7, 1. Okay, we are on point E. Let's locate that. That is down here. So that would be quadrant 1, 2, 3. Quadrant 3. And let's find that coordinate. So starting from the origin, we're going to go to the left, you can see, and then down. So it's going to be negative and negative. Left, down. Okay, so negative 1, 2, 3, 4. And then down, so also negative 1, 2, 3, 4, 5, 6. So left 4, down 6. Negative 4, negative 6. Okay, I have to make sure and double check myself. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Yeah, perfect. Okay, our last one would be point F. Again, not inside of a quadrant. This is on the x-axis. So let's just label that as x-axis. Okay, let's find that point. So we start from the origin. We're going to have to go to the left, obviously. 1, 2, 3, 4, 5. So I know it's going to go left 5. And actually, I'm on it. So if I don't go up or down any, then that y coordinate is just going to be 0. So negative 5, 0. Negative 5, 0. Okay, perfect. So hopefully that was a review for you and you've got that down. Let's go ahead and get to what's probably the new part here. Okay, we are going to learn about something called the domain and the range of graphs. This one specifically says of continuous graphs. Let's see, are they all continuous here? Yeah, they are. All right, continuous just means there's no breaks in the graph at all. All right, so there is a helpful way to find the domain and range. And we're going to fill in these blanks right here, and that's why I have these little like fake pencils on the screen. So domain and range can be kind of tricky. If you look at your practice sheet, that's actually like the majority of the practice sheet is practicing finding domain and range. I do think this will be the most challenging part of the worksheet. I think the rest of it's pretty simple, the stuff before it and the stuff we'll talk about after it. But it is also the most important because you will do domain and range throughout the rest of your math career. Okay. Domain just means the set of the x values. Your range is just the set of your y values, and that's kind of a little bit in the definition of them up here. So to find the domain, we're going to scan our pencil. Okay, this is just, you don't have to do it this way, but it's helpful to do this. You're going to scan your pencil left to right and identify the x values in which you are touching the graph. Okay, so let's fill that in. Scan our pencil left to right. Okay, and for the range, because that's our y values, we're going to scan our pencil. We'll say, you can say like low to high, bottom to top, or top to bottom, but you really want to go in a specific order. Let's say scan your pencil bottom says and left to right, bottom. I would say actually bottom to top. Makes a little bit more sense reading it. And identify the y values in which you are touching the graph. Okay. And it has a little note out to the side. It says domain and range of these types of graphs are usually written using inequalities or in something called interval notation. I don't want to give you both because I don't want to overwhelm you. Most likely in Algebra 1, you will do more inequalities. It depends on your teacher though, so you may write these different than how we're doing here, but usually they go with the inequality route, and that's what we'll do today. And then by the time you get to Algebra 2, they kind of introduce this interval notation, but you might have a teacher that shows you both ways. So we're going to stick with inequalities. And when you see that word inequality, we're going to write them as like x is less than something or y is greater than something, stuff like that, okay? All right, so let's take a look at this. It says identify the domain and range of each graph. I'm going to zoom in here. All right, so again, the domain is the x values that this entire graph covers. And keep in mind an important thing here. When you have a graph like this and it has arrows on the end, it implies that this graph goes on forever and ever to the left and to the right, and also like forever and ever up, right? It's like going left and up and also right and up, okay? So an easy way to do this is to get your pencil, which I got my pencil right here. I'm gonna like do this little thing where I circle it so I can move it around. And I'm putting it on my paper, okay? Like I know I'm touching the graph like all here and here, right? If I have my pencil, it's definitely touching the graph at some point when I'm scanning it this way and this way. So what you want to do is find the lowest point or the furthest point to the left where it's not touching your graph anymore. Now this one's interesting because you might be like, well, it's not touching it here. But it is though, because if you have this arrow on the end, you have to keep in mind that this line extends forever and ever, and it is touching your pencil right there. So you have to think, well, how far to the left would I have to go to where the graph's not touching it anymore? And it's going to touch it forever. Now, keep in mind also, our pencil is like finite, right? Like it ends right here and right here. But think about that pencil extending forever, like top to bottom in both directions also. And if you scan that, notice it's always going to touch your graph infinitely to the left forever and ever, okay? On that same note, if you scan it this way, it's touching the graph, touching the graph, touching it. There's no breaks in the graph, and the same thing's going to happen to the right. It will always touch the graph if you do a straight line up and down, because that graph goes to the right forever and ever also. And we have an infinite pencil that goes up and down forever, okay? So our domain would be every single x value. There's nowhere that this graph stops and cuts off other x values. So hopefully that makes sense. Now when this happens and every number is included in the domain to the left and to the right forever and ever, we can say our domain is all real numbers, okay? And there's, you could write it as like ARN. I feel like that's a less common way to write it, all real numbers, but it's easy. It's like a little shorthand way. But there's a little symbol that you guys are going to see this year that your teacher will use. I'm going to go or, and it looks like this. It's like a capital R, but it's got like these two lines on it, like this. That means all real numbers. So I'm going to say that is my domain, all real numbers. Okay, hopefully that made sense. I know that's a little bit of a challenging topic when you're first learning this. Let me move this pencil out of the way. Because for our range now range is the set of y values. So I'm kind of scanning my y-axis. And an easy way to do this is using a pencil but laying it this direction and scanning low to high or bottom to top, okay? Now, if I scan this way, I want to see all the places that this pencil is hitting my graph. So like I know all right here, I'm definitely hitting the graph, right? Pencil's hitting the graph for sure. But if you look down here, your pencil does not hit the graph at all, right? The graph is all contained right up here, all right? So you can find a lowest range value. So if I say, what is that value? Okay, I'm not touching graph, not touching graph, not touching graph, boom! I'm touching it right there. My pencil's kind of fat, so I'm just gonna move it out of the way for a second. So my lowest y value would be right here at this point. And then what point on the y-axis is that? Well, that's -2. So my range values, I'm going to say, is all the y values that are greater than or equal to -2. because it definitely lands on -2, and then it looks like it covers everything above that forever and ever. Let's double check that. So boom, it hits it at -2, and then keep in mind that pencil is imaginary, right? It's extending forever in both directions. So it's definitely hitting the graph at all these points, and it's still going to hit it forever and ever and ever because this graph keeps going up in both directions. Yes, it's going out, but it's also going up forever and ever and ever. So my range values, I would say it's all my y values, so I would just write y, that are greater than or equal to -2. And that's how we write it. So everything greater than or equal to -2 would be -1, 0, 1, 2, 3, etc. forever and ever. But nothing less than that -2 point. So I know inequalities can be a little bit tricky. Hopefully you understand that. But that's it for domain and range. Let's try it out on this next graph. See if I can bring my pencil over here to help us out. Let's bring this one. And we'll just scoot this one over here. Okay. Number 2, let's look at our domain value. So again, domain means the x value. So we scan the x-axis left to right. We want to find like what's our lowest x value to the left, what's our highest x value to the right that this graph covers. So this one will not be an all real number situation. If we take our little pencil here and I scan left to right, I'm definitely not hitting the graph at all over here, right? There's definitely a hard starting point, boom, right here. And then it's touching the graph, touching the graph, touching the graph, touching it, boom, still touching it, but then it's not over there. So this one has like a lower bound and an upper bound of where the graph is touching. So if we look at where those points are, it's clearly hitting the graph here, and then it's hitting all these points inside, and then it stops right there. So you can kind of think of it as like the whole graph is contained between these two pencils or these two vertical lines here to here. So let's look at where those points are. So that point on the x-axis would be at -1, 2, 3. So that's at -3. And then if we go this way, that's at the point 1, 2, 3, +3. So our x values are contained between -3 and +3, but nothing outside of those. Now, whenever you have a lower bound and an upper bound, you're going to write it like this. You're going to put an x down because domain is always x. And then I want you to do the signs like this. Let's do kind of just memorization for now. We'll talk more about it at a different time, and you guys will go more into inequalities throughout the year. But I want you to put your lowest number over here, leave a little space in between them, your highest number over here, okay? And then I literally want you to just do the signs like this. Boom, boom, kind of like open to the right, okay? If you read it from the middle, this says the domain is like all your x values that are greater than or equal to -3 and less than or equal to +3. So basically in between -3 and 3. And this is how you'll write it when you have a lower number and a higher number. Okay, let's look at our range. Let's see here. My face down here is kind of in the way of the range. Well, let's look at our pencil. Let me bring this one down. All right, let's zoom in here. Now, let me erase my markings so we have a good look at this. And I will get this one out of the way. All right, our range is our y value, so we're going to scan it low to high. Now, if I start way down low, it's not touching the graph, not touching the graph, boom, it's touching our graph. And it continues to touch it until boom, right there, and then it's not touching it anymore up here, okay? So we can tell our range has like a lower and an upper bound also, just like our domain does. Let's look at those points. I think they're the exact same, right? Just on the y-axis. So we have a point here and then up here, and our y values are everything in between those points and including those points. So -1, 2, 3, so -3 on the y-axis, and then +1, 2, 3 on the y-axis. So our range is going to look almost exactly like our domain. Think about what the only difference might be. Well, range is y values. So instead of having an x in the middle, I'm going to have a y in the middle, but it's going to look the exact same. I'll have a -3 here and a +3 here, and I'm going to do the same inequality symbols, okay? So let me move this. I would say it's all the, oh, it's difficult. It's all the y values that are greater than or equal to -3 and less than or equal to +3. Trying not to write on my face in the corner. And that's it. Now you may be confused when I'm saying, wait, you just said greater than, but that's a less than symbol. It's less than if you read it left to right. It reads left to right as -3 is less than or equal to y is less than or equal to 3. But if you read the inequality starting with like y coming out of your mouth and you read it this way, y would be greater than or equal to -3 and less than or equal to 3. Again, I know that can be a little tricky. That's always tough for kids, the inequality signs. Don't worry too much about it for now. Just know that this is how you will write them every time with domain and range for now. Okay. Last part right here, we have a couple more domain and range practice problems. If you feel ready to try these, go for it. Pause it, check it. Otherwise, let's go through it together. 2 more of them, and then our last part of the notes is going to be actually really easy. All right, domain and range for number 3. Let's scan left to right. And some of you guys may not need to use the pencil thing. After a while, you can just kind of scan with your eyes and be able to tell, but we're going to stick with the pencil thing. So I'm going to take my pencil, put it on the left-hand side of my page. It's definitely touching my graph. It's touching it, touching it, touching it, and it's touching it here. There's no breaks in the graph, and there's no lower or upper bound where the domain ends. And if you notice, we have arrows again on this one. It's going to go that way forever. It's going to go that way forever. So if you picture extending both directions, we're going to have another all real numbers domain. So I'm going to do like my little capital R with the little double thingy on it. All real numbers for domain. And you're going to notice that's always the case when you just have a straight line going off in both directions forever. And it's actually going to be very similar with the range. Take a look at that. So the y values. We're going to turn our pencil this way and scan it low to high. Well, you might be like, wait, there's no graph down here. There is here. And there's no graph up here. But guys, keep in mind, and this is where you have to visualize, because I have an arrow going out, but also down forever. Yes, this is going down forever. Slightly, it's not straight down, but it is going down. You got to keep in mind, because this is going off this way forever, and that pencil, picture that extending forever that way, they will intersect, and that's always going to happen no matter how low we go, because that line is going down. Same thing, y'all. This one's going up forever, right? Well, we don't need this pencil for this one. Oops. Come on now. Can I move it? There we go. But you can still picture it with this pencil. If it goes up forever and it's going out this way, those two things are definitely still going to intersect each other. So the range, because the graph goes infinitely down and infinitely up, is also going to be all real numbers. And that's it for that one. Okay, I know it's a little bit of a tricky concept. Hopefully you're following some of this though. Okay, let's try number 4. Let's get our pencils. Domain, we are going to scan it left to right first. Let me bring this one up over here. Okay, so if I scan left to right, let's start with like putting it on our graph. It doesn't look like it's hitting it here, but keep in mind we do have arrows on the graph, and if it's going, yes, it's going down, but it's not straight down. It's also out to the left and right forever. And because of that, you really have to visualize that it's going like out and out. So you're not going to find a lowest X value point, because it's still going to be hitting that graph at some point infinitely down. And it's hitting it, 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 hitting it forever and ever. So this graph is going to have another all real numbers domain. Let's write that. And let's see if the range is the same. I think range might be a little different on this one. Okay, let's take our pencil, let's scan down. Well, this graph is clearly going down forever. We're always going to have a point where we can hit the graph. Let's keep scanning up. Scanning up, we're still hitting it, still hitting it, still hitting it. Oh, boom, there is a top point here, y'all. We're not going to ever hit the graph up here. There is no graph to be had up here. So let's see where that cutoff point is. It's definitely right there. So from our origin, that would be at 1, 2, 3, 4, 5. So at where y is +5, it includes 5 because it hits 5, and then it includes every y value beneath 5, so less than or equal to 5, but nothing greater than 5, okay? So the way we would write that, there's not two numbers, okay? So you don't have to do the y value where you have two numbers on both sides, because there's a highest point, but there's not a lowest point. So this would just be a case where you say it's all your y values that are less than or equal to this number 5, because they're all down here. So all the y values that are less than or equal to 5. Again, think of that as like there's nothing greater than it, but everything less than it is included. Okay, I know that one was a little bit tricky. Let's cover our last part here, over functions. I think this one's going to be quite a bit easier for you. All right, function. Let's first write just a really basic definition. So a function is a special kind of relationship between your x and y values. So go ahead and write this down. It is where each input, or each x value, has exactly one output, or y value. So let me give you an example first of what a function is, and I'll have you guys write down this example. And there's so many examples we could come up with. I'm just going to write a basic one here. I'm going to give you 3 coordinates that would represent a function. So let's say the coordinate, I don't know, 2, 5. And we'll just do a few points. -1, 0. And 7, 4. Okay. Now I'm going to put these like curly brackets around it. Your teacher will probably do this a lot. Whenever you have just a set of coordinates, you'll see these little curly brackets put around them. Not the most important thing that I want you to focus on right now, but I'm going to just so you're familiar with that. This would represent a function. You may be saying, why is that? They're just 3 random points. Let me show you what would not be considered a function, and then we'll kind of compare it to the definition, and hopefully then you'll understand why. It's actually a pretty simple concept. All right, I'm going to make up 3 points that would not represent a function. Here we go. I'm going to say, let's do that first point again, 2, 5. And then let's do 2, 8. And then, I don't know, let's do -5, 0. All right, here is another set of coordinates, but these ones do not represent a function. Okay, let's look at why. So notice in our definition, it says each input has exactly one output. So each x has to be linked to one y value. Now, if you look over here, look at your x values. I have 2 being linked to 5. I have -1 being linked to 0. And I have 7 being mapped to 4. We're good there. All unique x values. Where we run into an issue is over here. We have 2 being mapped to 5, but then we also have that same number 2 being mapped to 8. And each input, which is your x value, has to have exactly one output. Over here, you have an input value of 2 that has 2 output values, 5 and 8. So because, and you know what, on your notes, I would underline the fact that you have a repeating x value over here of 2. That is why this fails, not a function. So really what you have to look for specifically is if your x value repeats, not a function. Okay, specifically if it's being mapped to more than one y value. Now, it's okay actually if your y values repeat. So make sure you're looking at like the first number in each set. And if you see 2 of them that match each other, it's not going to be a function. And it's pretty simple when you look at it like that. So let's look at this first 4 here. It says, determine whether the given relation is a function. So this is just either a yes or a no. So number 1, you want to look specifically, scan through and see if you see any repeating x values. I have a 5, a 3, a 2, a 0, a -1. That all checks out. They're all unique x's, none are repeating. So I would say, yes, this is a function. Cool. Yes, check mark. Check number 2. Let's see, we've got a -2, a 0, a +2, a 3. Oh, and another +2. Look at these guys. And let's double check. 2 is being mapped to -4 and it's being mapped to +4. That cannot happen in a function. So no, this is not a function. Okay, let's try the rest of these. All right. Number 3, let's check them. We have a -4, -3, -2, 1, and -3. You gotta have a good eye for these things. -3 is being mapped to -1 and also 2. That can't happen in a function, so nope. Let's check our last one. Let's skim through here. We've got a 1, 2, 3, 4, 5. We're good there. Yes, this would represent a function. All right, so that's how you look at it if it's just coordinates. Here's a little bonus part right here. This could be a little bit more challenging. Now it says determine whether the given relation is a function, but they give you a bunch of graphs. So you could like write out all the coordinates and then figure it out from there, but I'm going to show you a little trick method that you guys will definitely talk about in class. And I want you to pause the video and write this off to the side. There is something when it comes to determining if a graph is a function, there's something you should check called the vertical line test. All right, so it says if a vertical line intersects a graph more than once, it's not a function. Let me show you how this works. Number 5 here, if you can draw a vertical line anywhere on the graph and it hits the graph in more than one point, then it's not a function. So for instance, like over here, that's just hitting the graph once. This is hitting the graph once. This is so far we're good until here. Vertical line, boom, boom. We hit 2 times, and that cannot happen in a function. So this one we would say fails the vertical line test, so not a function. And it says determine whether it is a function. I'm just going to say no with an X. And think about how this actually makes sense. What if you wrote out these coordinates? Well, that would be the coordinate -1, 2, 3, +1. So -3, 1. And this one would be the coordinate -1, 2, 3, -1, 2, 3, 4. So if I write that out, -3, -4. Well, check that out, y'all. That's just a repeating X value, right? -3 gets mapped to 2 different Y's. So that's why this vertical line test works, okay? Try number 6. Let's look at this one. This one looks like it's going to work. There's no points that are stacked right on top of each other. So no matter where you draw a vertical line, you're only ever hitting in one point on the graph. So this one's okay. This one we would say yes, it is a function. Okay, and these ones are pretty simple too. Number 7, it's not distinct points. It's what we call a continuous graph, but no matter where you draw a vertical line, it's only ever like hitting the graph in one little spot, right? There's no way it's going to hit 2 spots. So this one's good. We would say yes, this is a function. But number 8, as you can see, if you draw a vertical line anywhere over here, boom, boom, it's hitting in 2 points, which can't happen, right? It happens at a lot of points, right? So this would not be a function. No. Okay, we learned a lot of material in this one, y'all. The domain and range I know is going to be a little bit tricky. Go fill in and do all the ones you can on the practice sheet that you can. Let me bring this back up. And then definitely look for the practice video if you need a little bit of help identifying that. And I will see you in the next video.